Hello everyone, I'm Zlata from the FJD Trion team, and thank you all for joining us for this webinar on the Forest Mind module and QGIS workflow with FJD Trion. So to give you some background on this webinar, basically point clouds can capture an incredible amount of detail, and when we work with tree-related data, that means that there is a lot of valuable information inside the dataset. But in real projects, that is often where the challenge really begins. Because at first, when we have a dense and complex point cloud, it looks impressive, but it does not immediately give us clear answers. And that is the key issue. Raw data on its own does not automatically create understanding. So the real question here is, how do we get from all of that complexity to something that is actually useful? How do we identify the information that matters? And how do we turn it into something we can visualize, we can analyze, and use for better decisions? That is exactly what we want to show you today. So in this webinar, we will walk you through a focused workflow with FJD Trion and QGIS. We will start with a point cloud, then move into the extraction of tree-related information, and finally show how that data can be visualized and evaluated in a practical GIS environment. So this session is really about one thing: how to turn complex point cloud data into clear and useful insight. We're also very pleased to be joined by Nick from Scanflow Solutions together with his team. So thank you for joining us today. And also, by the way, this webinar is also a part of a broader QGIS workflow webinar series. So stay tuned for more sessions to come. Okay, so let's get started. And Nick, I'd like to invite you to introduce yourself and your team.
Before we dive deeper into the topic, let me briefly introduce ourselves. My name is Nick, and I'm the founder of Scanflow Solutions. And at Scanflow Solutions, we focus on turning complex spatial data into practical workflows and usable results, from capturing in the field to processing, analyzing, and the final delivery. And joining me today is my colleague Andrei. He's a GIS engineer and an absolute expert when it comes to transforming spatial data into clear, readable, and visually effective maps. So we want to share a workflow that starts with tree-related point cloud data and leads to structured information, clearer visualization, and practical GIS-based analysis. What you're seeing here is where the whole story begins. This is the data capture process, the moment where the real environment is turned into a digital point cloud. And that is what makes this technology so powerful in a short amount of time. We can capture a very detailed representation of reality. We're no longer working with just a few measurements or a simplified sketch. We are working with a rich digital model of what is actually there. And when you look at the rendered point cloud, you immediately see how much information it contains. It gives us geometry, structure, spatial relationships, and a strong digital base for further work. But at the same time, this is still only the beginning, because even though the point cloud contains a huge amount of information, it does not yet give us clear answers. It is still raw data. It is still unstructured in terms of questions that we want to ask. And it does not automatically tell us what is relevant. It does not automatically separate the objects we care about, and it does not automatically turn complexity into clarity. So the next steps will be about doing exactly that. This is where the workflow starts to unlock real value. What we have so far is a detailed digital representation of reality, but as powerful as the point cloud is, it is still only the raw starting point. To make the data useful, we now need to move beyond visualization. We need to identify the objects that matter, structure the information, and begin turning the point cloud into something that supports real analysis. And this is the case that means focusing on tree detection and extraction. So this is the point where we move from seeing the data to understanding it. And now I want to invite you to have a look at the full workflow inside FJD Trion Model using the FJD Trion Model Forest Mind module. So let me dive into Trion Model. So what we see right now is my prepared data set. We used to scan a couple of days ago a park with trees. Let me show you the raw data because this is already processed. This one here. Oh, yeah. Let me colorize it by RGB. So this is our data we captured with the FJD Trion S2. In a couple of minutes, we have a park with trees here, you can see. To extract the trees, you will need the Forest Mind module. So after processing, after point cloud mapping, this is our result we get. The next step will be moving into the Forest Mind module over here and starting the ground point extraction by choosing the dataset, extract ground points. Here we can adjust some parameters like grid size, ground thickness, and density sampling parameters. You can leave them as they are, but you can also try to play around with the parameters to see how the result will come out and which result will fit your needs better. I did this already. After you've done this, you will get this result over here. So what the ground point extraction does is it normalizes the terrain. So don't wonder that your point cloud is flat because the original point cloud has actually some differences in elevations. Your extracted point cloud will be always flat. You just need this as a step for the tree segmentation. And after it's done, you just hit the next button over here at the top, segment by tree. So using this button, we have two collection methods of the data. We used to collect the data handheld. We did not use the vehicle mount. So we choose handheld. And then you can leave the parameters as they are, but you can also try to play around with them. There's also advanced settings that will fit different tree types. You can play around with these, or if you're a professional, you may know what of each parameter will change. So let's stick with that one. After we hit OK, we will get this result here. And as you can see here, there are far more trees identified than I used to display here. Because for my task, I only wanted to display those trees inside this park. Those trees that I do not want to display, I just deleted them. So after we get this result, we can turn on the unclassified point cloud to have a look what happened here. And what I like to do is I display the tree IDs. By displaying tree IDs, you can identify where trees are and where trees shouldn't be. For instance, the algorithm detected this pole here as a tree. So what we have to do now is to merge those trees into one. For instance, we need to merge those both. We merge them together. And now we have to adjust this tree and delete the pole. So first we match them. Then we go to tree number 48. Let me exit the merging, search for tree number 48. And then we go to add tree manually. We select the pole. We add the tree. It will display as a new tree, but now we have to use the delete tree. Oh wait, should be the tree down here, tree 126 exactly. And now we hit on delete tree 126 and delete it. So this is the manual labor you will have to get the trees separated that you want to show. Let me turn on everything back again. Right here, yeah. And of course I prepared the data before, so I used to delete all of those trees that we do not need. I just deleted all of them and cleared the data. So at the end, let me show you what we got. We got this. Yeah. And the next step is, let me exit the tree deletion button. The next step is to create the cron analysis in order to collect and calculate the tree data. So we hit cron analysis. We can choose the algorithm, the accuracy, high, medium, or low. I'll leave it on high. Then we hit OK. After that is done, we can use the other buttons, but I usually create the property calculation, and then it gives you a report. The report looks like this. So you have your tree ID, you have the coordinates of every tree, you have the tree height, you have the diameter of the tree on a certain level. By the way, the level you can set up in the settings when you go to File, Settings. For forestry settings, you can like set up different parameters here. You can also set up the height on which the algorithm will calculate the dBH. So let's look at the report again. So we have a couple of different informations here. And next step is just export the data. And it will save as a CSV file with this data here, with this database. And later you can use this CSV file and import it into QGIS. My colleague Andrei will show you what you can do with the data inside QGIS. But before we go inside QGIS, I want to show you something else what we can do with the data that is also very handy. We can use the manual classification to classify different materials. Like if you look at this park, another use case can be to determine like the area of this surface you can see here. So let me display the point cloud by intensity first. So we see the differences in materials. So you can see here there is a path going like this. So what I used to do here is I classified manually exactly this path. I gave him a class. You can see here I classified different surfaces. I classified the trees, some other objects that you can see when you display the point cloud by intensity, for instance. This is a manhole, so you can classify them inside QGIS. Let me briefly show you how it's done. So we choose our point cloud dataset in the project browser. We go to manual classification. Then this window pops up, giving us some tools to pick points. And for instance, I want to classify this path here. But usually if you go inside, let me show you on another data set, for instance, for the P2. So this is the data set captured by the P2, the same one. Let me display this by classification. It's not classified, that's why I cannot display it by classification. So let's go to edit, manual classification. Usually you will have like all white points, so you cannot determine where the path is going. So by entering this the classification, you can still go to display and then hit on intensity, and the point cloud will display by intensity. You can also adjust in the settings the color scheme of your display. For instance, I like to pick brown yellow, and you can play with the saturation settings. So you can make some materials appear with a higher contrast. But I think this is okay for me. You hit OK, and now you just go and pick your tool and pick your points like this. I will show you briefly how it's done. So you start and classify the contours that you see like this. Then you choose the class. For instance, I want to give it the class 15, and This means our unclassified points will turn to class 15. You can choose another class color. Let's go with OK. And it is easier to classify this part when you, for instance, want to classify those points that are not belonging to your path. You can just leave class 15 unchecked, choose another class like ceiling, and then hit OK, and you'll get like a sharp line here. So you won't classify those points back again. Let me show you what will happen if you have some noise points like here. Usually you classify, let me choose intensity back again. Usually you classify from the top view. So after you choose those points here, you will also have, let me show it with a tree here as well. You will also choose those points here. So you could use, for instance, this workflow. Let me choose another class, 16, okay. Like this, you classify everything, then you exit, you go to edit data extraction, you choose the extract by category, and now you can extract class 16, for instance, or let's extract every class, okay. Now in your project browser, they may appear new point clouds at the bottom. Let me change this. So here are new points clouds. Let me display them. So we do not want to see the unclassified. We want class 16, and now we want to delete or to change those points. So we go back to manual classification, and now we can set our view like this, and then make them from class 16 to class unclassified. So this is how you get rid of noise points. So you make sure that you have only the ground points in your class. Class 16, unclassified. After you've done this with every class you've extracted, you could delete these as well. I usually used to choose all of those point clouds and then go to start merge. So I merge those extracted point clouds back to a full point cloud. And after this, you can display this one by classes again. Now you can see here we have our ground points classified without the tree over here. And basically you can repeat this kind of steps endless until you reach your final result and are satisfied with the result. So this is what I roughly did here. I classified different materials, different paths. If you have a look at the RGB, this is some green bushes here. They got their own class. You can really play around with this and build your own workflows, because basically every class can be treated like a layer in different softwares. And in QGIS, actually, you can read the classification of an LAS file, and that makes you work with the point cloud as a layer object. Yeah, so those workflows are just the basics. You can build different ones, and you can use other buttons in Trion Model as well. This is just one way of how you can do it. And now let's have a look at this data set inside QGIS. We will have a look at the CSV file that we have exported from the report we generated. We'll have a look how fast you can map those trees on the map, and we will have a look what you can do with a classified point cloud inside QGIS. So let me go back to my presentation. And I will show you a pre-recorded video of my colleague Andrei that will show you the way how it's done in QGIS. So now what have we have prepared and extracted the data. And inside QGIS is where the workflow becomes much more visual and flexible and even practical. So we start here with a clean QGIS project, and the first step is to bring the point cloud data. So we take the last file, add it into the project, and once it's... Huh? Oh, we're stuck. It's good? Okay. So we bring the point cloud into QGIS. At this stage, one of the first things we always want to check is whether everything is in the right place. As we scanned this point cloud with a GNSS receiver with an RTK module, we georeference the point cloud. So we verify the coordinate system of the project, zoom into the data and make sure the location is correct. A quick and very practical way to do that is to add, for instance, a base map, for example, a Google satellite layer or another reference layer, and visually compare the point cloud position with the real world background. This is an important step because we want to start analyzing or styling anything. We want to make sure that the spatial reference is correct and that the dataset is properly aligned. So once that is confirmed, we can begin organizing the point cloud for interpretation. What makes QGIS especially useful here is that we are not limited to just one visual representation of the same cloud. We can duplicate the same layer and display it using different attributes. And that gives us several ways of reading the same dataset depending on what we want to understand. So for example, we duplicate the point cloud layer and change the rendering from RGB to classification. That immediately gives us a different kind of view. Instead of seeing the realistic color of the same, we now see how the point cloud has been classified, and that helps us separate different object types much more easily. Then we can duplicate the layer again and display it by another attribute, for example, intensity, and this will give us another visual representation of the same data. So now we have the same point cloud shown in 3 different ways, like RGB, classification, and intensity. And it's very useful to have these 3 different representations inside QGIS. Because the RGB view is often the most intuitive because it looks closest to the reality. The classification view is very useful when we want to isolate specific classes, for instance, like a path. And it helps us understand the dataset that has been categorized previously. To keep the project clean, we can use a group of layers, so we can layer those different types of visual representation of the point cloud into a group, and that will structure our layer inside QGIS even more and gives us a better workflow to change smoothly between the different types of representations. Yeah, and now we're already moved into an analytic example. For instance, in this project, we can identify a path or a trail in the classified point cloud. That is what you see on the screen right now. And let's say that we want to extract the area and quickly calculate its surface, the surface area of this path. And there are different ways to do this, but we'll show like one of a practical ways how to do it using the raster to vector workflow. And we start with the classified data and select the relevant class. In this case, we use this path. And we rasterize that information. We define a resolution, and depending on how fast we want the process to be, we can choose and redefine the values and the parameters. For a quick first result, a slightly larger cell size for the raster is often enough. Once the raster is created, we convert it into a polygon. And now we have a real vector object representing the path area that has been previously classified inside the point cloud, inside Trion Model. And that is already very useful because now we have no longer to work with only points from a point cloud. We actually have a polygon that we can style, label, and analyze. And at this stage, we can switch off some temporary layers that has been created inside QGIS and focus on the polygon result. We can give it a color. For example, we can make it pink or red. As you can see now inside QGIS, the brown polygon has been created based on the point cloud we have classified before. Now we are giving it a different style, for instance, pink or red, and we can create a filling so it becomes clearly visible in the map. If the outline looks a bit rough because it was built based on the point cloud, we can simplify the visual appearance by adjusting or removing the boundary line and emphasizing the fill instead, making it a little bit little thicker. And this will give us a cleaner representation of our polygon. So now we changed the lines, make them thicker and thicker, and removed the boundary lines. So we have the according path on our map inside QGIS. So now that we have the polygon displayed, the next logical step is to calculate the area. For that, we use the field calculator inside QGIS, and we create a new attribute for the area, define the unit we want to use. So we use the polygon, and we calculate the geometry value. Once that is done, the polygon stores its area directly inside the attribute table. So this is some basic functionality of GIS. And GIS is actually very, very powerful to analyze data. So after we have done the calculations, we need to label it. So we add the label, call it area, and use the field, the area that has been calculated previously, to print it onto our map. We activate labeling, choosing the area field, placing the label inside the polygon, and we can also add like a small buffer around the text to make it more visible on the map. Those are some small things that you can do in QGIS to increase the visual appearance of your data. But there are several different styles on how to do it. Now you can see the point cloud with all of the classes displayed. Let's turn them off again. Yes, so this was a great example on how quickly point cloud, classified point cloud information can become usable GIS information. We started with a classified point cloud, extracted a feature, converted it into a polygon, calculated the area, and labeled it clearly on the map. And those are exactly kind of steps that makes the workflow practical for project communication. Yeah, so now let's move to trees. For this part, we already have the CSV file that we previously exported from FJD Trion Model, and we are going to import this CSV file inside QGIS. So we load the CSV file, define the X and Y coordinates, and if available, we can also include the Z values. Then we assign the correct coordinate system and add the data into the project. As soon as we do that, the tree positions appear as points. So now we have the tree data specially located in QGIS. That is already a useful starting point, but of course we want to go further than just displaying points. What we want is to transform these points into something that gives us a stronger visual representation of the trees. And one very good way to do that is to generate crown polygons. So we're going to generate crown polygons based on the data we exported from Trion Model. You can see them now on the screen. Now they are appearing according to the trees given in the point cloud. And yeah, to achieve this, we can use the geometry generator that is built inside QGIS. And here we create a polygon geometry based on the location. So we have the location of the trees from the CSV file, and we have the crown related attributes also from the CSV file. In this case, we use the crown diameter to generate those circles and use the coordinates of the trees as the center point. And since the radius is obviously half of the diameter, we used the formula and divided the value by 2. And that gives us a circular crown representing for each tree. So once we apply that, we immediately get a much more meaningful view of the tree data set. And instead of only seeing point locations, we now see approximate crown extents. That makes the data much easier to interpret, especially. And when we want to understand spacing, overlap, or distribution of trees, this will help us to create precise maps. So in QGIS, we have now to export the generated geometry and save it as an actual polygon dataset. That gives us much more room to work with. And now we can start designing the tree layer in a more meaningful way. For instance, display those polygons based on tree heights. And those tree heights are also stored inside the CSV file that we've exported. So here we displayed tree heights based, we displayed the trees based on tree height. The red circles are representing smaller trees. The blue circles are representing bigger ones. And when we look at this result, we can immediately see how those trees are sitting in the environment. We can even detect a design when we look at those trees. At the bottom, we see more smaller trees, and at the top, we see the bigger ones. So this gives us a much clearer view on how in what way those trees are sitting in the park. This can be useful for landscape architects capturing documentation of parks for creating new designs, for instance. Yeah, and next we can add labels. For example, we can label the trees as well by height. Again, with a small buffer around the text that helps to increase the readability, especially when we add a background to the circles. It can become visually complex. So that's why we add always a small buffer around the text. And now we're no longer looking at an abstract data set. We are looking at a structured tree layer with visible geometry, and that is colored by different heights. And we have the height labeled inside the circle, so we can see at the first glance which tree has which height. And if we want to analyze the trees in a profile view, we can create lines through the data set. So for example, we can Again, duplicate the layers, switch off the unnecessary symbology, and then use a geometry expression to generate a line. At first, this may again be virtual geometry, but just as before, we can convert it into a real line feature. So once the line exists as an actual layer, we can save it and style it so it stands out clearly in the map. And for instance, we choose a bright color and a slightly stronger width. This will be useful to represent it better on the map. Now with this line in place, we can move into the profile view. And this is a very interesting part of the workflow because it allows us to inspect the trees from another perspective instead of only looking at them from above. We can look at sections or profiles and understand their vertical dimensions much better. And yes, this is actually possible inside QGIS, not only in software that supports or have lots of point cloud features. We can do it actually in QGIS as well. So now we should have the point cloud appearing in the section right there. What you also can do is to use those round circle polygons to cut out each single tree and save them in a separate LAS file. This is also possible. So at this point, we already have quite a rich GIS project. We have the original point cloud in different visual modes. We have extracted and labeled a path polygon with a calculated area. We have imported 3 points from the CSV file. We have turned those points into crown polygons. We have styled the crowns by height. We have labeled the trees, and we have created lines for profile-based analysis. And all of that comes from combining extracted data with the flexibility of QGIS. And this is where the workflow really starts to demonstrate its value. Because what began as a complex raw or semi-processed data is now becoming structured, visual, and understandable. So the next step is export and presentation. As you know, in many projects, we do not just want to explore the data interactively inside QGIS. We also need to create outputs that can be shared with others. And that could mean images, reports, PDF files, or CAD-based handovers, DXF files, vector lines, or simple QGIS databases. So for example, if we want to pass geometry into CAD environments, we can export the relevant layers. We select the geometry we want to transfer, define the export settings, and save the result in a format that can be opened in software like AutoCAD. So we can save every layer that we've created previously, like the path we have classified inside Trion Model. We can export this as a polygon in a DXF format, which will also be georeferenced. We can use this for further workflows inside AutoCAD, for instance. And of course, it's always worth checking the results after export, just to make sure the geometry has transferred correctly and that each feature behaves as expected and is also georeferenced. And besides CAD export, we can also prepare visual deliverables directly in QGIS. So, for example, after we checked the data in AutoCAD, we can create a 2D map view and a 3D view, even a 3D view in QGIS. We can even combine both of them with profile outputs and place them on a layout inside QGIS and print it on a paper on a PDF format. So let's go and create a 3D map. So inside QGIS, we can create 3D maps, set the view, and use this exact view to print it or to bring it on a layout. And this is quite very powerful because different stakeholders often understand data in different ways. Some people prefer thematic maps, others respond better to profile graphics or 3D perspectives. And QGIS gives us the flexibility to prepare all of these views from one project environment. So by the end of this process, we are no longer dealing with a raw data set that only can be read by experts. We have turned it into a project space where information can be explored, measured, styled, labeled, and viewed by anyone. And this is the key message of GIS. Make data visible and structure it. So you can see now the final step is bringing our data on a layout, and you can design your layout however you want it to design. Basically, we can talk about this topic endlessly. So let me switch over and show you the end result that you can expect. You see here we have our trees as a base layer. We use the colorized point cloud. We have our polygons that we generated. They're colored by height. You can see the labels here. We have our path here, also color displayed with those red lines. We have a base map showing the location of this park, and we added a 3D view of some trees, for instance, to show. Yeah, and basically this is a small breakdown of this workflow. I hope everyone enjoyed it. Thank you for listening. And this will be and hope you see you again in our next webinar. Thank you.
Yeah, thank you so much, Nick and Andrei, for the great presentation and for sharing your practical experience with us. And of course, thank you everyone who took the time to join us today. We hope that this session was useful, informative, and inspiring for your own projects and workflows. If you have a workflow that you would like to share in one of our future webinars, we would be happy to hear from you. So please reach us at mkt@fjdtrion.com. Because innovation grows when people share what works, and great workflows deserve to be seen. So thank you again, and we look forward to seeing you at our next webinar. See you next time. Goodbye, everyone.